Hello, everyone. Again, welcome to our webinar on RoboClean, which is our automated point cloud cleaning solution for scanned floor data. Really happy to talk to you today. My name is Catherine Brill, and I am the product manager for RoboClean, and I'm a member of the products team within the larger KCI organization. KCI is a leading civil engineering firm with offices throughout the United States and a focus on technology and innovation. And I'm here today with a variety of other people on our team, Carl Keller and Kayla Rossi. They are the two developers of RoboClean. I'm also joined by James Clay, who is our 3D scanning leader and the technical visionary behind RoboClean, and Jay Kwan, who is the RoboClean sales engineer. So today we'd like to talk to you about RoboClean, really discuss pain points that users have when cleaning their point cloud data and how RoboClean can help optimize that process. So to begin with, let's talk about why cleaning point clouds is so important. It's a critical step in handling and processing laser scanning data, especially when it comes to analyzing scan data of very flat surfaces for floor flatness and levelness analysis. Point cloud cleaning removes artifacts that could significantly distort further analysis and measurements and ensure that the scans represent the actual floor surface, because even small amounts of noise could possibly skew the surface deviation calculations and lead to incorrect assessments. So as you can see from this slide, that there's a variety of reasons why cleaning point clouds is such an integral step to further analysis of that point cloud data. However, the challenge comes with the massive scale of point clouds. A 3D laser scanner can capture as many as 2 million data points per second. And that means those point clouds are so large and so dense that it does not make for efficient transfer and storage of the files, and that increases overall costs. Those large point clouds can also consume significant computing power, which exceeds the capabilities of standard computers, and it requires high performance hardware to avoid slowdowns. And in general, cleaning point cloud data involves a variety of time-consuming manual steps. So with our new RoboClean solution, you now have a powerful cloud solution for cleaning scanned floor data. RoboClean is specifically designed to handle large data sets. Its targeted focus is on floor slabs. So removing the gear that's found on the ground, left on the ground, pallets, hoses, etc., from the point cloud data so that it can be processed further. RoboClean generates very fast and reliable results, delivering industry standard E57 and LES files that have the ground and non-ground points classified and ready for the next workflow. And a cloud-based automated solution for point cloud cleaning, such as RoboClean, really addresses those issues that I had mentioned in the slides before. With this type of scalable solution, as I mentioned, massive data sets can be processed quickly. RoboClean does replace tedious multi-step workflows. It allows staff to keep their workstations free and maintain their local computing power so that staff members can work on and focus on other analytical or visualization tasks. It reduces CPU bottlenecks by offloading that very computational intensive cleaning operation to the cloud. And it eliminates hardware constraints and setup time because RoboClean is available in the cloud. So I wanted to go over in this slide and really emphasize how easy it is to set up a RoboClean uh, run. It's essentially 3 steps. You upload your scanned data of the floor via our bricks interface, and I'll be demoing that in just a minute. And then there are just a few parameters that you can set to adjust and choose your complexity of your cleaning job that you want. Um, Really, you can specify low, medium, or high cleaning options. You can specify distance from scanner parameters. These parameters help you to improve the RoboClean classification by allowing you to clip within a certain distance of your scanner's setup and or clip points that extend beyond a specific distance parameter. You can even upload a DXF file to define project boundaries and exclusion zones. So these parameters help you adjust the cleaning operation, the precision of it. And then once those parameters are set, all you need to do is the third step, which is run the model and access your results. RoboClean, as I'd mentioned, is built on a scalable infrastructure. It's going to process files very quickly, and then you have your results right there at your fingertips, ready for you to download or to use in another workflow. So here's a very brief, and I'm going to actually have James in a few minutes discuss the output in more detail, but I wanted to give you an example of kind of a before and after shot of this is a point cloud before it's been cleaned by RoboClean versus after. So that gives you a good example of the cleaning operation that it does. Now, I've been talking about cleaning your file, uh, that kind of pre-processing step before you go into another workflow. And here I'd like to talk to you about what another workflow could be, which is a RoboFlat. So RoboFlat is our innovative advanced solution for concrete floor flatness and levelness analysis. So you can combine RoboClean and RoboFlat for a more automated pipeline for that concrete floor uh, flatness and levelness testing. It is really streamlined, so data is all in one place, and it really increases your efficiency in your floor flatness testing by being able to access RoboClean essentially in the same place as RoboFlat, and then input those RoboClean out-generated files directly into RoboFlat. And I'll be demoing that in just a minute. And this gives you just more information about that integration between our RoboClean, our point cloud cleaning process, and then our RoboFlat, which is our point cloud processing solution that is looking to test the flatness and levelness of concrete floors. So I'll be demoing how that integration looks like, but really wanted to stress how convenient that is to have RoboClean there for RoboFlat ingestion. All right. So Now I'm going to go into a demo. I should have mentioned this in the beginning of the webinar, but I'll do it now. We really want this webinar to be as interactive as possible. So if you have any questions while I'm talking or James is talking or you see going through the slide or the demos, please just use your chat and type it in, and we'd love to answer any questions you might have. So this is our gobricks.com website. It is the platform that offers RoboClean, and anyone can access it. Just go to gobricks.com. Has a variety of advanced machine learning or computational models that anyone can use. And I know we're going to be talking about RoboClean, but if you have other use cases for your industry that you need a machine learning model or a computational model to address, please check out gobricks.com and look at our catalog. In this particular case, we're going to be talking about RoboClean. When I click on my details button, you'll see more information about RoboClean, its use case, how it is purpose-built to use with RoboFlat, and we also go through the required inputs, which is RoboClean ingests E57 files, both unstructured and unified. And then, as I'd mentioned, it outputs two different files, an E57 file that contains only the ground points, and an LAS file that includes both the ground and non-ground classifications. When I log into this gobricks.com, the first thing I see is a personalized data set. Personalized dashboard that shows me information about my models and the data sets that I've processed. I can upload data by clicking on the data sets option on the left-hand side of the page and selecting my Create Dataset button. And here I can drag and drop my E57 files right into the interface, and that data set will be created. Once the data set is created, then you can run that data through your RoboClean model. When your model runs are done, you can click on Results and see your results. View and access and download your results right from this page. Going back to my catalog, I wanted to show you RoboClean and step you through an example of what it's like to run your E57 file through RoboClean and then actually access that cleaned file through RoboFlat. So if I have my RoboClean model here, I select Run Model. I'm going to filter for E57s, and you see here that I have uploaded a noisy point cloud, or a point cloud that has a variety of artifacts still on the floor. It hasn't been cleaned. So I can select that file, select Next, and here is that parameters page that I had showed you earlier. Now, you can enter a friendly name for your model run so that you can distinguish it in your results page. And then here you can specify your cleaning complexity as well as your distance from scanner and upload your DXF file. We have a really handy illustration. When I click on the I button, it shows you exactly what our RoboClean filters and processes will do to the point cloud, depending on the cleaning complexity option that you have chosen. And gives you a really great visualization of what a specific point cloud will look like based on the parameters that you have set. Um, and I'm going to actually, if it's okay with you, James, stop here and see if you wanted to add anything more about what RoboClean is doing at this point with the different parameters.
Yes, yeah, no problem.
Thank you.
And please interrupt anybody who has a question about it. So, uh, one thing that the different levels will allow for. So RoboClean can clean very minute detail off the floor, but sometimes that can be too much detail. And so what the different selections give you a chance, because it returns an E57 or an LAS file, or I mean it does both. You could download the LAS file if you wanted to finish cleaning some really tight artifacts or something like that you need to get off the floor or get out of your surface or roadway surface or something like that. If you needed to take that information off yourself, uh, because it really there's a step in between low, medium, and high, just because it will high really cleans very small artifacts, but it also can over clean. The good thing about the LAS file, and this is how we handle it, I always use in my group, we always use high. So then we'll open up the LAS file, which has all the classifications in it. They're separated, and we'll go and pull some data back in that was considered to be noise on the floor, which typically it over cleans a little bit, but it does a great job at cleaning everything else. And so you can kind of see from those some of these shots here where this is a classification view of it's showing the floor that was leaving behind and everything it cleaned off automatically. And really on these floors, we may do 500,000 to a million square foot floor scanning. It has all this equipment, people on it, and lots of gear on the ground. And it was taking our group, one person that could clean that data. It could take 12 to 15 hours for one person to get through that. And so that's really where this came from, is that was just, there was no way for us to continue and to keep up with as much work as we have. So this was developed so we could just push that off, and we'll set it on high and let it clean and over clean some. And you can see, by the way, that some of the purple that's on the floor is an over clean spot, just because I can tell from the classification what I'm looking at. But it's cleaned everything else for us automatically. We'll go back in, use that classification, and just draw a circle around those couple of purple areas and say, hey, give me those points back in our local desktop software. And we'll get those points back. And now our floor is ready to submit with just those floor points back to RoboFlat if we're doing testing that way, or if we're using it for some other type of deviation or some type of test where we're looking for sinking of flat slabs, things like that. Or if it's on a roadway where we're just trying to get an asphalt or pavement report to so that we can see the cracks and everything are left behind after the data's run through. So, and ultimately though, as you drop back to medium, it will leave more gear on ground on the floor. Low probably will not clean off hoses and things that are on the floor. If a hose is 12 millimeters or a half inch or something like that, or larger, uh, or smaller, it probably won't clean that off on medium, and it definitely won't clean it off on low. But that again, it just depends on how clean the floor already is when you submit it, or your pavement or whatever it might be that you're submitting. If you already know a lot of that real small stuff is not on there, just choose low. It runs, then you won't have as much over cleaning to deal with. However, if you know that the slab was terrible, you couldn't get in touch with all the contractors, they couldn't get off the floor, who can stop working, right, just to have you come in and scan, then you use high. And here, it does a great job at cleaning that data off. We also include, with ours, we'll typically take our building CAD file and we'll drop in a cell for all the columns. That's a 1x1 or 2x2 square. And so that will, RoboClean allows you to also select that DXF file. And so the first thing it does is it goes through and clips out all the holes of the columns and things like that, or any other areas that you didn't want it to RoboClean to have to try to deal with. Areas that you scanned that you were picked up, walls and things on the outer edges, you can have that DXF automatically clip that information. So you have two different line types there. One is interior, one exterior. So anything outside the exterior that line that you've drawn on your CAD file, it clips out and it all goes away. And everything inside, any interior lines there on interior layers will clip inside. So all our columns will be interior or machinery, big, large machinery, box folders or something like that we know are there. We'll go ahead and just have a real quick CAD file that really speeds up the process and gives us back a more accurate cleaning, just because RoboClean doesn't have to go through and look at those other anomalies that are very odd to it while it's trying to figure out where the floor is, or the very flat surface that you're looking for. So that's basically what that is. I know, and if I'm confused, y'all can certainly ask me questions.
Thank you, James.
Welcome.
So then once you have added those parameters and specified how you want the cleaning operation to run, you select Next, Run Model, and then RoboClean starts processing that data. Now, one last thing I wanted to show you was actually how RoboClean output can then be fed into RoboFlat. So as James mentioned, RoboClean outputs a E57 file that has all the non-ground points removed automatically, and it also generates a LAS file that has both ground and non-ground. For RoboFlat, we need a cleaned E57 file to continue that floor flatness and levelness analysis. So when I select Run Model, I can very easily access my RoboClean results just by tapping on that RoboClean results tab. This is a file that I ran earlier yesterday, I guess it was, in preparation for this webinar, because I wanted a cleaned point cloud that I could feed directly into RoboFlat and continue uh, my point cloud processing workflow, all from within the Bricks platform. So just a single click and you've got your RoboClean results ready for further analysis. All right, I'm going to switch back because I do want to open up this, make sure we have time for questions and answers. The one thing that I did want to stress is our licensing options for RoboClean are very flexible. We have a free trial that gives you access to all of RoboClean features. So that means you can run RoboClean on your own data to evaluate whether it works for your particular operation. And there's no commitment required in order to do that. We also have two different paid options. One is a subscription plan. We offer both monthly and annual billing options, and that is ideal for users who are going to use RoboClean on a regular basis and want to take advantage of some discounted pricing. Um, for the more casual user of RoboClean, we have a pay-as-you-go option. So this is absolutely no monthly commitments or minimum usage required. Instead, you purchase credits based on how often you want to run RoboClean. And each time you run RoboClean, that run consumes a certain amount of credits. I think it's a pretty low amount. And then once you run out of credits, you buy more if you want to run RoboClean again. Very, very flexible. That pay-as-you-go option is perfect for occasional users or specific project-based work. So now I think I'm going to hand it over before we open it to Q&A, which I really hope you guys ask us some questions. We are very excited about this new technology that we've been able to bring to the market. It's different from what's out there today. I'm going to hand it over to Jay Kwan, our sales engineer, to talk about next steps.
Thank you, Kathy and James. Thanks for attending to today's webinar. And if you'd like to try out, here is a link that you can definitely easily to create your accounts. It's a cloud-based format. So you can, as long as you have an internet service, you can try out freely. And during that time, if you have any questions, you can always reach out to me and I'll be able to help you in the pre-sales education process.
And I do want to put in a plug for our blog. We've published recently a variety of articles about point cloud processing um, in regards to RoboClean and also RoboFlat. We have a case study as well as cell sheets that are available from the blog. So I highly encourage you all to visit that blog. Thanks, Jay, for sharing the pricing page. As you can tell, RoboClean is very cost effective to use, requiring very minimal amount of credits and in order to process your point cloud data. And I think we're right a little after time. So thank you very much for spending the time with us to listen to listen about and learn about RoboClean, and we appreciate your support and hope to talk soon. Thank you, everybody. Bye.
Thank you. Bye-bye.